sodium inside the cell as outside, which means equal sodium concentration inside and outside cell. The osmolarity just for sodium is the same inside the cell and out. The total osmolarity is still unknown. The water will move from the cell into the solution, not anymore. The water will move nowhere. That's not actually true. It moves back and forth all the time. It will net move nowhere. There will be no net change in the amount of water inside or outside the cell. Because the water moves from low solute concentration to high, if they're the same, it's not going to move. So the cell will eventually be the same. So, relating this to what we're about to talk about, thinking back to our interstitial fluid in our extracellular compartment. One of the main functions of the interstitial fluid is to maintain an isotonic environment, so that when you all of a sudden get this giant influx of potassium, or you all of a sudden get this giant influx of sodium, by the time it's gone to the interstitial fluid, you're maintaining a relatively constant bath around those cells, so they're not likely to shrivel or blow up. It's this barrier, so all of a sudden, if your blood concentration goes from 3.5 to 5.5 just from eating a meal, you're not all of a sudden getting that same immediate shock to those actual cells. That water buffers that shock so that maybe, instead of going from 3.5 to 5.5, it's hanging out at a pretty constant 4 for potassium. And then so things can go in and out of the water, and then the cell doesn't get such a big shock at the beginning. Okay, so to finish this example, so these are isotonic to each other. Isotonic and isotonic. There are different cells in our body that have vastly different concentrations of these different ions for specific purposes. But the extracellular fluid around them tries to maintain a gradient and a concentration whereby there's no mass impact on any given cell. So your extracellular fluid can absorb a little bit more of those concentrations in any given area. Okay, so now there's one more. Any questions on this one? Isotonic being equal. Condition D. Now I get to finally change this unknown osmolarity. Okay? So, there is, we'll just make it more. This would be true also for less, but we can make it true for, we'll just do more right now. Because otherwise we'll be here all day. Okay, there's more sodium inside the cell than outside. That means that there's higher sodium concentration inside the cell. The osmolarity just for sodium is higher inside the cell. The total osmolarity is the same. So, the cell and the solution have the same total number of components. What's going to happen? It turns out that the water will still move from solution into cell. But it's complicated. So here's why it's complicated. If you're only concerned about water and sodium, relative to sodium, this exact same thing is true as condition A, right? There's more sodium inside the cell, there's less sodium outside the cell, so the water's going to rush in and burst the cell. But if at the same time you have less potassium inside the cell and more outside the cell, right, then water's going to go from the cell into the solution. And then if you add chloride into that, then you've got water movement in a different direction. So by the time you've got 40 different solutes, you cannot tell what the net movement is going to be based on one thing. You have to, rush water into the cell, and if it's isoosmolar for everything but that sodium, which really wouldn't make sense in the case of osmolarity, you can get movement. In other words, do you get how complicated it is? Like, it starts to get really complicated. I'm not going to have you add up total solutes and determine net water movement. What I'm pointing out is, if I give you this question, you should know that if I ask just about water and sodium, or water and any one ion, that the net movement is into the cell. If I ask about the total number of net movement, the answer is different. You can't, even though they are isoosmolar, you can't tell what the net water movement is going to be unless you know all the pieces and add them up back and forth. So that's all this last one is. Okay, so, and then cell will eventually be question mark, right? And so I'm just going to write, but it's complicated, just to mean that. So that's usually if I give this in a sequence question, like a couple, depending on how I give it. A lot of times I'll walk people through all these conditions, and this last question is usually one of those, all right, so what do you think would happen if this would happen? Give me a reasonable explanation for why this would happen. And you don't, in those types of questions, you don't have to necessarily be right, but if you give me a reasonable explanation for why you think that would happen and your theory is right, then you get the question right. Like, it's not usually an add these three things together and tell me what happens, it's why is this maybe happening? Okay, I'll leave this up for a minute. But